Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over how to add and subtract monomial expressions. This standard is covered in Algebra 1, Algebra 2, College Algebra, and also pre-calculus courses. Don't forget there are 18 practice problems at the end of this presentation for you to try out to test your skills. To gain access to our entire playlist, just take a look in the link in the description below, and you also get a link to the worksheets where you can practice your skills. Alright, the instruction for the examples that we're going to be working on is as follows. We are to simplify the following if possible. Okay, alright. For question number 1, what if we were to simplify the sum of monomials 8x plus 7x? Now, something to keep in mind is that in order for you to combine monomial terms, the two terms must be like terms. Okay, think about it in terms of currencies, for example. In order for you to combine two components of a currency, you have to have an identical type of currency, like $1 plus $2 is equal to $3, right? You can't say $1 plus 2 pounds is equal to $3 or 3 pounds. That makes no sense. You need to have like terms in order for the terms to be combinable. Now, how do you know if terms are like terms? Well, if you direct your attention to the checklist we have on the right hand side here, these are the steps we're going to be using to verify if terms are like terms, and then we will proceed to combine them. If they are unlike terms, then we will not be able to simplify the sum or difference any further. Okay. All right. So the first thing to do is you want to take a look at the coefficient of the monomial terms. Make sure they're in the same set of numbers, either rationals or irrationals. In that case, you should be able to combine them. Our focus today will be on rationals. All right. When you're dealing with irrationals, then you want to take a look at the radical component and see if they're identical in that case. Are they like irrationals? But we're not going to do this right now. You deal with this in Algebra 2. So we just focus on rationals. Step 2 is verify that the variables are identical. And then lastly, step 3, the powers of the identical variables have to be the same. Okay? All right, let's take a look at these two terms we're adding here, 8x plus 7x. The question is, are these two like terms? Let's look at the coefficients first. 8 and 7 are both integers. Okay? Integers or whole numbers or natural numbers. What do we know about integers? Every integer is rational, right? So these two coefficients are both rationals. All right, so pass the first test. And then if you look at the variables x and x, both variables are identical. Okay? Because we have an x and an x, okay, identical variables. And then if you look at their powers, are the powers the same? Well, the x and the x do not have powers because their powers are invisible, okay? So if you don't have a power specified, the default power, invisible power, is 1, okay? So the power of the x variable is 1 for the first term, and the power of the x for the second term is also 1. So we have a check for all three cases. Coefficients of both rationals, variables are identical, and the powers of the variables are the same. Okay, so let's go ahead and combine. To combine, what you do is you add the coefficients and you bring down the variable. All right, so let's make a side note here. These two terms are like. They're like terms, so we can combine them. Okay, so 8 plus 7 is 15. And then you just bring down the variable, the identical variables, x to the first power. Since the power is 1, you don't have to write it, okay? So there goes your answer for question number 1. All right, let's take a look at the next question, number 2. What if we were to simplify negative 13y squared plus 4y squared? Okay, let's take a look at these two terms and check to make sure they are like terms. The coefficients negative 13 and 4 are both rationals. They're both integers, and we know every integer is rational. So negative 13 and 4 are both rationals, which is good. The variables are identical, y and y, and their powers 2 and 2 are the same. Okay, So can we combine them? Absolutely. These two terms are like terms. So we can combine them. You just add the coefficients and bring down the variable. Negative 13 plus 4. Different signs, subtract and keep the sign of the bigger. Negative 9, and then bring down the variable component, y squared. There goes your final answer. Number 3. What if we were to combine the terms negative 10 ab, let's write that again, negative 10 a cubed bc plus 4a cubed bc. All right, let's see if these are like terms. Coefficients, negative 10 and 4 are both rationals, okay, which is good. And then let's look at the variables. We have ABC, ABC. Variables are identical. Excellent. And then let's look at the powers of the identical variables and verify that they're the same. For the A's, we have 3 and 3. For the B's, we have the invisible variable power 1 and 1, the same. And then for C, the invisible power 1 and 1. Okay, so since the coefficients are in the same set, rationals, the variables are identical and the same power, they are like terms. What does that mean? We can combine. Combine the coefficients, bring down the variables. Negative 10 plus 4 is negative 6. And then bring down the variable a to the third bc. Okay, that goes the answer to question number 3. All right, let's take a look at question number 4. So for question 4, what if we were to simplify the following? 15 x squared y minus x squared y. Okay, now if we take a look at this expression right here, what we're going to first of all determine is, are these two like terms? Okay, so we look at the coefficients and ask ourselves, do they belong to the same set? The coefficient of the first term is 15 and the second term does not have a coefficient. So what is the coefficient here? You have the invisible coefficient, which is 1. Okay, so there's an invisible 1 right here. Okay, all right, so 1, negative 1 and 15 are both rational numbers, so coefficients are in the same set. Excellent. The variables xy are the same, and let's look at the powers. The x's have powers of 2, and the y's have the invisible power of 1. So 1 and 1. Okay? All right, so these two are like terms. What does that mean? It means that we can combine them. You combine the coefficients and bring down the variable component. 15 minus 1 is 14. Bring down the variables x squared y. Alrighty? And that goes the answer to question number 4. All right, let's take a look at the next problem, question number 5. So for question 5, what if we were to simplify the expression AB plus 11AB? All right, so first question is, are these two terms that we're adding, are they like terms? Well, let's look at the coefficients first. The coefficient of AB is the invisible coefficient, which is 1. So if you compare 1 and 11, you find out that both numbers are both rationals, okay? And then AB are identical variables, and their powers are 1 and 1, the invisible power, okay? So coefficients are in the same set, variables are identical, and their powers are the same. What does that mean? We have like terms, ladies and gentlemen. So we can combine them by adding the coefficients. 11 plus 1 is 12. And then bring down the variables a, b. Alrighty, so there goes the answer to question number 5. Alright, let's take a look at number 6. Number 6, what if we were to simplify the expression negative 6a squared b squared minus 5a squared b squared. Alright, so first of all, let's see if they're like terms. Coefficients negative 6 and negative 5 are both rationals. Variables identical AB, and the powers of the identical variables are the same, 2 and 2. These two terms are like terms, so we can combine. Okay. All right, what do we have? Combine the coefficients, negative 6 minus 5. The signs are the same. You add and keep the sign. So negative 11 a squared b squared. That is the answer to question number 6. All right, let's take a look at number 7. What if we were to simplify the expression negative 3mn plus 4mn? All right, are these like terms? Coefficients are both rational, the variables are identical, and the powers are identical also. So these are like terms. Combine coefficients, negative 3 plus 4 is positive 1. And then just bring down the variables mn. Okay, so you don't have to write down the coefficient. If it's 1, just write mn. And that's the answer to question number 7. All right, let's move on. Question number 8. So for question 8, what if we have to simplify the expression 1/3 cd squared plus 1/2 cd squared? Now, let's look at the coefficients. Are they both in the same set, either rationals or irrationals? 1/3 and 1/2 are quotient of integers, so they are both rationals. And then let's look at the variables. We have identical variables, CD, CD, good. And then the powers, C and C both have powers of 1, D and D have powers of 2. Ladies and gentlemen, we have like terms here. What does that mean? We can combine them. Combine leading coefficients, so we have 1/3 plus 1/2, okay, and then CD squared. So how do we combine 1/3 and 1/2? Well, we have to find the LCD, right? That's how you combine fractions. The denominators must be the same first, and then you will combine the numerator and keep the denominator. The LCD of 3 and 2 is 6. That is the smallest number that 3 and 2 can go into. So we want to make the denominators both 6. Okay, so the LCD of 3 and 2 is 6. So you times this one by 2 top and bottom, and then you times this by 3 top and bottom, and that yields 2/6 plus 3/6 CD squared. Okay, now let's go ahead and combine the fractions. You add the numerator 2 plus 3, which is 5, and keep the denominator 6 CD squared. That's the answer to question number 8. All right, let's take a look at number 9. So for number 9, let's say we're to simplify the expression negative 10xy squared minus 10xy squared. Okay, now if you take a look at these terms, you can easily see that they're like terms. Ladies and gentlemen, they are exactly the same. So if you have two terms that are exactly the same, you don't even have to go through all the steps we did. You can clearly see that they're like terms. Okay, so we combine coefficients. Minus 10 is minus 20. And then you bring down the variables x, y squared. And that's the answer to question number 9. All right, let's take a look at number 10. For number 10, what if we were to simplify the expression negative 18 ac squared d plus ac squared d? Let's look at the coefficients first. Negative 18 and the invisible coefficient here, which is 1. How about rationals? Check. ACD, variables identical. Powers. A's have powers of 1, C's have powers of 2, D's have powers of 1. Identical powers 2. So these two terms are like terms, which means they can be combined. Okay, so we add or subtract the coefficients. Negative 18 plus 1 is negative 17. And then we'll bring down the variable component, AC squared D. Okay, so that's the answer to question number 10. All right, moving right along, number 11. What if we were to simplify the expression 3AD plus 4BC? All right, let's determine if they are like terms or not. Coefficients are 3 and 4. They are both rationals. Good. And let's look at the variables. Are the variables identical? There's a to the 1 here. There is no a at all on the second term. These two terms are unlike terms. So what does that mean? We cannot combine them together. So it's already simplified completely, ladies and gentlemen. It's just we end up with exactly what we started with since they're unlike terms. Okay, so just remember, unlike terms cannot be combined or simplified. All right, moving along. Number 12. What if we have three terms? What if we have 4b plus 7a minus 18b? Okay, let's see what we have here. If you take a look at 4b, we have three terms here, okay? 4b and negative 18b are like terms, but 7a is not similar to those two, okay? So if you underline 4b and 18b, they're like terms. Why are they like terms? Because their coefficients are both rationals, okay? And the variables are both b's and the powers are 1. So we can combine those two. 7a has a different variable, so it's not like to the other two. Okay, so we'll combine the like terms. Well, let's bring up 7a first, since a is first in the alphabetic order. So bring down 7a. And then 4 minus 18, remember you just add or subtract the coefficients. 4 minus 18, you subtract and keep the sign of the bigger, negative 14b. That's the final answer to question number 12. All right, let's take a look at the next one, question 13. What if we were to simplify the expression 3w plus 7z plus 5w minus 2z? Okay, now what you notice here is that we have two set of terms that are like terms. 3w and 5w are like terms, so you can combine them. And then 7z and 2z are like terms. Alrighty, so let's go ahead and do it. So 3w plus 5w, you add the coefficients, 8, bring down the variable, plus the z's, 7 minus 2 is 5, positive 5, and then you bring down the variables z. Okay, so there goes the answer to question number 13. All right, let's take a look at question 14. For question 14, what if we have m square n plus 13 mn square minus 7m square n? Okay, so let's see if we can identify like terms here. Mn square has a coefficient of 1, the invisible coefficient. All right, all three terms have a coefficient that are rational, so that's good. And then let's look at the variables. The variables are identical, excellent. And then if you look at m, this has m squared, this has m to the These two are unlike terms, since the power of the m is 2 and the power of this m is 1. But the power of the last term matches the power of the first term. Okay, and if you look at the n's, this has n to the first power, which doesn't match this, which is 2, but it matches the last one. So the first term and the last term, guess what? Are like terms. So we can combine those two. You add the coefficients, 1 minus 7, subtract and keep the sign of the bigger, negative 6, bring down the variable, m square n. And then the unlike term, 13mn square, you just bring it down, plus 13mn square. And that's the answer to question number 14. All right, let's take a look at question 15. For question 15, let's say we have the problem presented in text format. So for question 15, let's say we're to find the sum find the sum of y squared and negative 3y squared. Okay, so first things first, we're going to translate this into algebraic format and then see if they like terms and combine afterwards. So what operation does the word sum suggest? Sum represents addition. Okay, so what are we summing? We're summing y squared and negative 3y squared. So if we translate this into algebraic format, we have to look for y squared minus or plus minus 3y squared. Okay, so we are adding y squared plus minus 3y squared. Let's go ahead and multiply these signs out real quick. Remember, anytime you're multiplying signs that are different, your resulting sign will always be negative. Okay, so it's y squared minus 3y squared. Now, are these two terms like terms? Let's look at the coefficients first. Y squared has the invisible coefficient 1. Okay, 1 and 3 are both rationals. 1 and negative 3 are both rationals. Excellent. Variables identical, y's, and their powers are the same, square. We have like terms here, so we can combine them. Okay. Combine the coefficients, 1 minus 3, subtract and keep the sign of the bigger. Negative 2y squared is the answer to question number 15. All right, let's take a look at question number 16. So for question 16, let's consider another problem in text format. What if you were to find the difference between negative 5x squared y and negative 15x squared y. Okay, what if you were to find the difference between these two? All right, let's do it. So first things first, we're going to express this statement in algebraic format. So the word difference suggests the operation subtract. Okay, we're going to be subtracting this term and this term. Okay, so we want to find the difference between them. So we're going to rewrite this as negative 5x squared y minus negative 15x squared y. Okay, now if you notice here we have two signs next to each other. Let's resolve those signs. We're going to multiply them. Anytime you multiply signs that are the same, the result is always positive. In the previous example, we talked about multiplying signs that are different. In that case, it's going to always be negative, okay? But when you multiply identical signs, the resulting sign is positive, alrighty? Plus 15x squared y. Alright, so next question is, are these two terms like terms? The coefficients are both rationals, good. Variables are identical, xy, xy, and the powers of each identical variable are the same, 2, 2, 1, 1. We have like terms here, ladies and gentlemen, so we can combine. Coefficients, minus 5 plus 15, subtract and keep the sign of the bigger, positive 10. And bring down the variables, x squared y. All right, so there goes the answer to question number 16. Alrighty, let's go ahead and take a look at the last question, problem number 17. So for problem 17, what if you were to simplify the expression in text format? You were to subtract 10a from negative 11a. How would you do this? All right, so since this is in a verbal format or word format, we're going to proceed by first converting it into algebraic format. Okay, so when you're subtracting, so just something to note, okay, the way that is written is the reversal of how it's written in the algebraic format. So if you subtract, something to note, if you subtract x from y, okay, this is the verbal format. If you want to write it in algebraic format, it's going to be y minus x. Okay? So just keep that in mind. The way it's written is the reverse of how it's written algebraically. So if you're subtracting 10a from 11a, algebraically is written as negative 11a minus 10a. Okay? All right, so do we have like terms here? Coefficients are both rational. Variables are exactly the same with identical powers of 1. We have like terms. So we can combine. Let's go ahead and combine. The signs are the same. Add and keep the sign, negative 21. And then bring down the variable a. And that's the answer to question number 17. Alrighty, now how well have you mastered the examples that we went over? We'd like you to try out the practice problems that we're about to display. You just work on them, and then after you click on you pause it, work on it, and then you click back on play, and we'll show you what the answers are. Alright, so stick around and take a look at the practice problems. Alrighty, to demonstrate mastery of the problems we just went over, here are 17 practice problems we'd like you to try out. So what you want to do at this time is pause this video presentation and then go ahead and solve these 17 problems. And then when you're done, click back on the play button, and then we're going to display the answers for you so you can check to see what you got wrong and the ones that you got correct, okay? Alrighty, so hopefully you had a chance to try out these problems. Let's go ahead and display the answers. So answers coming up. Alright, for number 1, the answer is 7x. For number 2, it's negative 7x. Negative 7x, the answer for number 2 is negative 6y squared. The answer for number 3 is negative 14a squared bc. For number 4, the answer is 28x squared y. For number 5, they're unlike terms, so it just stays the same, 5ab plus 7ac. For number 6, the answer is negative 12a squared b squared. For number 7, the answer is mn. For number 8, the answer is negative 40 xy squared. For number 9, the answer is 7 over 20 cd squared. For number 10, the answer is going to be negative 29 ac squared d. For number 11, the answer is 8y plus 10z. For number 12, the answer is 4a plus, this is a 9 right here. Sorry about that. This is supposed to be a 9. It looks like an AB. Okay, so for number 12, just fix that. It's not an AB, it's 9b. Okay, so it's going to be 4a plus 8b. Sorry about that. Number 13, the answer is 18y squared. Let's try that again. 18y squared minus 24y. For number 14, the answer is 2m squared n plus 12m n squared. All right, so 14 is it's 4m squared n. So number 14 is 4, because 6 minus 2 is 4m squared n plus 12n squared. Okay, good, that's it. And then for number 15, the answer is negative 12y squared. And then for number 16, the answer is 4x square y, 4x square y. And then for the last one, the answer is negative 24a. Okay, so these are the answers. Go ahead and check it out. All right, so we'd like to know, how well did you do on these practice problems? If there are any questions that you'd like us to explain further, just put it in the comment section below and we'll be more than glad to address it. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your studies of operations of monomials, adding and subtracting monomials, do give us a thumbs up or a like. Your positive feedback is very valuable to us. Don't forget to subscribe to our channel. We upload videos to our page on a weekly basis. So subscribe and also hit the notification button so you can get notified for our future uploads. As indicated earlier, if you have any questions or comments, just post it in the comment section below. And don't forget to visit our website, Mathgotserved.com, where you can gain access to practice tests, worksheets, games that can help you master algebra. Thanks again for watching and have a wonderful day. Goodbye.